And if we don't have something which are not matched, we should use the different types of the converter to match generation with the consumption. Anyway, so for this case, you see that, first you need to see the nature of the generation and nature of the load. So now we have a concept, we call it microgrid. Does anybody know what is the microgrid, and explain as easy as possible? What is the definition of the microgrid? Arya, do you know what is the micro? Okay, good. I mean, my idea is to say you can say no. Okay, microgrid. Does anybody can say, I never heard this microgrid in all my life? How many of you guys heard the word microgrid? Shaking, actually. So, you don't know what is microgrid, and you never heard about this? Okay, good. Yeah, this is good. So, assuming that you have a building, and thank you for honestly saying these things. Yeah, if I ask Arya, yes, I know what is microgrid. Yeah, but explain, I don't know. Okay. Anyway, I mean, assuming that you have a building, just a simple example. We have a building. So you can provide the electricity for your load in this building. Okay? So do you need to buy electricity from distribution line? No. Okay? So this is one example. And another thing, you have actually generation in your home and the grid is unstable. Do you prefer to buy the electricity from unstable grid, or you prefer to provide electricity for yourself from your generation? Which one is better for you? From generation, yeah? Do you agree? Okay, so the role of microgrid is this. We provide electricity for ourselves, and we have this possibility to isolate it from the grid when the grid is not stable. When we are talking is not stable, it means that, I have electricity and grid is also okay, but it's in a peak time and I'm not going to pay for the electricity during the peak time, so I use my own generation. But the message is that this type of grid or building that I have or I'm living has this possibility to be separate or isolated from the grid. Okay? So this is microgrid is a part of the grid which can be connected or disconnected from the grid, or can be disconnected from the grid when we have some issue in the grid, and then can be connected to grid when the issue is solved. So when we have connection with the grid, we call it grid connected mode. And when we are disconnected from the grid, we call it isolated mode. So, or islanding mode. So it means that we have a generation and load, nothing with the grid. Okay? So we can provide electricity without having the connection with the grid. So just a simple example is here. So we have this possibility to be connected with the grid, and this is the load we have. We have an energy management system, but we have this building. We can provide the electricity from PV. We can actually use the electrical vehicle for charging and discharging. And also we have this diesel generator, battery, and flywheel, but we have also DC loads and AC loads. So this type of actually, so it's a combination of the generation and consumption. And we cannot say that, I can connect my building to power plant and consider as a market. No. We use the local power generation in a small scale and provide all or part of our consumption. So just this type of actually technology can provide more reliable. Why? Because it is disconnected from the grid and we provide electricity for ourselves. It is more resilience. If a storm happening, something actually disconnect the transmission line, we can provide electricity from ourselves. It's more efficient. We have generation close to the consumption. It is more environmental friendly. We can use the PV, wind, and this type of local generation for that one. It is more secure, so it means that we don't have this distribution and transmission line. This attack cannot happening. It's easier to control because we have a generation close to consumption, and we can easily, if the consumption increases, we can just turn off one load and make the balance, but there are some other actually. Secure to issue occurring elsewhere, so it's like the photo I shown you. If fault happening here, several actually kilometers far from here also get affected. So by this technology, it is not somehow affected by somewhere else. So capital investment can be scaled over the time. So it means that after spending some money, it's returning back because you don't pay to the distribution company. Microgrid can be integrated into existing system. If the government lets you, you can provide electricity and sell it to the convention, to distribution grid. And it can use the combined heat and power, like using the fuel cell, provide the electricity and heat, and after that use the heat for some actually thermal activity. So seems that this is a nice technology, and also we can use it different places. So some simple example is like here. So this is a microgrid in Sendai in Japan. So it's a combination of the main grid, gas generation, fuel cell, PV. And in this building, so if a storm happening, you have access to provide electricity for some sensitive loads. So it can be provided by battery energy storage to supply by the PV or fuel cell, and then use the conversion system to provide electricity for that. But the main interesting part is for the remote places, when you have actually some small village far from the distribution or transmission line. You don't need to somehow provide a new transmission line. So this is an example of the village with 638 population in, if I'm not, Alaska. So we have a diesel generator which provides 1.6 kilowatt and also wind with 400. So by these two combination of these two generation, we can provide the electricity for these 600 people. Okay. So microgrid can increase the resiliency of the system, because when the storm happening, we can provide electricity for our system. Then the grid, if 1 week out of the order, you can also use that one. So if it's fine, we can stop here, then go to lunch, and then continue after lunch. Yeah? Okay. Thank you. No question? No? Okay. You're hungry? Okay, good. Arya, you're hungry? Okay, good. I mean, you're like sometimes yes, sometimes no, but depended the situation for you. Yeah? Very smart. Yeah, thank you. Yes. No, we see this one, okay? We see this one. A DG, yeah. Look at this one. This is your answer. Is there, okay? I explain the next. next session.
Like the lunch is going to be served in the house, okay? And it may take another 10 minutes. Meanwhile, you get prepared for yourself and get ready for the lunch.
Was it clear for you? Yes? Yes or no? Yes? What is the microgrid? Tell me. As easy as possible.
It is a part of a grid.
Tell me. No. Look at me. Can say smart grid is like a building. It provides electricity for the loads. Can be disconnected from the grid or connected to the grid. Tell me. You're showing.
It is a type of grid which
Can be disconnected from the grid when we have some problem in the grid, and then again connect the grid when the problem is solved. Yeah? Excellent. So, now it's clear?
Yes.
Okay, good. I mean, I normally ask the person that first say yes. Once say yes, I hear something yes. Yeah, okay, I get back to you. So, don't worry. Did you wash your face? Okay, I mean the teaching will be finished when you feel sleepy, okay?
I have taken strong coffee.
Okay. With milk? With you? It's cold actually. So anyway. So Arya, the previous session was clear for you?
Yes.
Yeah, what is the microgrid?
We are just answered the same question. Microgrid, I think you have not.
If you remember, okay, what I told him about him, I said that, when I'm teaching, he's feeling sleepy. So, or physically in the class, look at me, but his mind is somewhere else. So now he said that you didn't explain. Yeah, so, yeah. So, okay. You are not going to say something? Should I repeat again?
No.
It's clear for you?
Yes, yes.
So what is the microgrid?
How do I explain?
Yeah, tell me.
I'm asking you, how do I explain?
You can as simple as possible. Assuming that you are going to
Microgrid is like we consider a very small area
very small area.
for the generation, and it's like whatever is given it through it, it's for not for large amount of usage.
Okay.
Like in simpler words.
But this is distributed generation. This is not microgrid.
This is
Distributed generation source. This is not microgrid. This is a small area generating electricity for usage. Yeah? So it is distributed generation technology. My question is, what is the microgrid? So get back again the question. Was it clear for you?
no.
Okay. Should I explain again to you?
Yes.
Okay, good. Yeah.
I'll just grab my pen.
Okay.
Back side.
Are you ready to listen to?
Yes,
I think he's the only son of the family, yeah?
No.
The brother?
Younger brother.
Younger brother. Poor younger brother. No, it's like a lovely man. He take care, hey, please do this one, supporting, this is why, not bad brother, a good part. Yeah, okay. So, I mean, in some cases you don't need to memorize something actually, microgrid is this one. No. You should understand that what is the mission of the microgrid, okay? So, we have power grid, we have microgrid. So you should recognize that microgrid shouldn't be big grid. It's otherwise the name was not microgrid. So microgrid is a part of power grid. So what is the meaning of this? Power grid is generation, transmission, distribution, and consumption. So this building is consumption side of the power grid, but it's supplied by the grid. It's a grid connected load. So when we provide our electricity for our building, this building can be considered as a microgrid. Why? Because we provide electricity for ourselves. So we can be independent from the main grid. So microgrid is a part of the main grid which can be disconnected from the grid if something wrong is happening in the grid. And then if it was recovered, we can return back the connection mode. So for disconnection from the grid, we need to provide our electricity by ourselves. So it means that we have some local power generation which can provide electricity for ourselves, so we don't need to be connected to main grid. Is it clear for you?
Yes, not.
What is microgrid?
Microgrid is a system in which we produce energy in small, like not basically small, but for the household usage for ourselves, and we are not dependent on the main station.
Yeah.
So like it's for ourselves, and whatever the energy is produced, and it's not connected to the main main line, main transmission line.
New generation of microgrid. Yeah. Okay. Yeah, excellent. Thank you very much. Thank God also. Anyway, so I mean, basically, when we are talking about microgrid, and we need to understand the concept, because later you can work in this direction rest of your life. You can go forget this part, or probably you. And this is a very interesting topic that we need to know and have a deep understanding about. And the reason is that lots of, I mean, at least in European Union and lots of advanced community and countries, they are planning to reach carbon neutrality by 2050. So it means that we don't have any generation from this fossil fuel, and we provide electricity from different types of the renewable energy sources. So it is important to see that, you know, if it is possible to support all the consumption by the renewable energy, or do we have any possibility to provide all, energy from all consumption from this technology or not? So one aspect is that we provide electricity with the big wind turbine, and then we have the power plant, or solar. We have also transmission, distribution, and this type of things, and then support the loads. But it doesn't mean that we cannot use the other potential. So the concept of the microgrid is coming from this aspect, that you can provide electricity for yourself and support your own load. So this is important. But this is not that much easy that we define it. Because you can provide electricity, then reliability, stability, and security, and lots of other things are needed to be considered, and any of these targets can be researched for several years. So this is important, you understand what is it. But at the end of the day, you should clearly say that microgrid is a combination of the local power generation and consumption, which also have the possibility to be connected to the grid. So now I have a very easy question. Considering this, this one. We provide the electricity, and with the inverter we provide the power to the load. So if we disconnect this grid, then provide the electricity for the load. Is it microgrid or not?
Yes.
Yes. Why?
Because the energy generated by the solar panels are basically getting used at home appliances and other devices.
Yeah.
Though it is not getting forwarded to the MSCBs.
Oh.
Hybrid.
Do we have any constraint for the microgrid or not?
Maybe the high power appliances won't
May
work.
can damage the devices.
IT? What?
High powered appliances won't work. Maybe that can be a thing, or maybe it
Yeah.
won't be for working for a long time. If all are working, it will be consumed in a very short time.
Yeah. It can be some constraint or existent, or some solution are also existent, but this is also true that sometimes generation is less than consumption. Yeah. And what is the interaction with the power grid? Do we need to have power grid or not?
But like you said that it is disconnected, right?
So if disconnected, then we should consider this source. Okay. So we said that we have residential conventional PV system grid are not microgrids, but they are distributed generation sources. And the reason is that if we disconnect the grid, it doesn't work. Because they have synchronization with the power grid. So if we disconnect the main grid, it means that the voltage is zero, and this converter, the output of the converter will be zero, the voltage, because it provides a reference based on the grid. So for this reason, this is not a microgrid. This is distributed generation technologies. So for the microgrid, when we use the local power generation, it should have a functionality to react as a voltage source. But what this works is like a current source. We call this type of technology grid-connected operating mode. So it means that when it is connected to the grid, it works. But that one I'm going to talk later is grid forming. It means that it can act as a voltage source, not current source. Okay, so this is the difference. So if you see this one later, and as this is a microgrid, you can say, okay, depends. If the controller is designed in a way that if disconnected, then it can continue, create the voltage point at the output of the converter. This is microgrid. Otherwise, it is grid-connected distributed generation sources. Okay? Did you get it 100% clear? So.
Second,
Okay.
if the grid experience power outage,
Yeah.
the load cannot be powered even when the sun is shining.
Yes.
Even you have a lot of PVs connected.
Yes, because it cannot be, because it cannot work like a voltage source. It cannot create the output voltage. It has the current control. Yeah. So let me explain in a more clear way.
It's like load is huge enough to serve the power.
No, this is not because of that. Okay, good. Yeah, it's makes sense actually. Okay, so this is a converter. Okay, So this is a DC bus, and this is the output. So we have a filter and transformer. So we make the equivalent. So I will ask after this explanation. Okay? So pay attention carefully. So we inject the current because the voltage is fixed here. So S is V times 2I. So we can create the power. Okay? But this voltage is fixed. And accordingly, this voltage is also fixed. And then the current changing, so we can play with the injected power. So if voltage is 10, then current can be 2, 3, 4, 5, and the S can be 20, 40, 60, and okay? So we can control the current, so by this, control of the current control loop, okay? So it said that, based on I need in the grid or load, so I can give the order to the converter, and converter inject. So for example, if you have a, I don't know, this is the grid, and this is the load, and load is 10, then I make the measurement from the load and say that, please tell Mr. Converter inject 10 ampere, and converter inject 10 ampere. And then I change the load again, and the load current go to 20, and I said that now inject 20, 20, inject 20, okay? Yeah, yeah, voltage is constant, yeah. And the controller is coming from this voltage of the grid, okay? But when outage happening in the grid, voltage go to 0. So then it doesn't provide reference for that one. So you cannot provide it, it goes shut down. So for this case, when we use the PLL, does anybody know what is the PLL? Okay. What is the phase lock loop? What is your name? Anirudh. Anirudh. Okay. So what is the PLL?
In which we phase lock loop, in which we check the phase difference
Between different. Repeat again your name. Anirudh. Okay. My target student, Anirudh. So okay, but thank you very much. At least this is not expecting from the bachelor student to know. So it seems that you know something good. So phase loop, okay, is like this. So I get the use the PLL, and then in PLL we have the voltage of 3 phase, okay? Then the output will be frequency and theta, okay? So by this, I can control my converter and say my converter that when you synchronize, it should be in phase with the grid, okay? So for example, if the grid current is like this, okay? And in this time, 46 degree, for example, you are going to integrate your converter. You connect your converter to the grid and inject 10 ampere. So if you connect, it should be this match with this degree. So it's like this one, okay? Otherwise, it makes some unbalanced situation for that one, because then it is not matched. So assuming that we start from here to here, okay? So what happened here? Here current is negative, here is positive. So for example, is the grid, -3, having +3, we have -3, okay? So it makes the problem. So this PLL provide the theta for us, the instantaneous angle of the grid, and say that when you connect to the grid, you should be matched with this, so your starting point is I max sine omega t plus theta. Okay? So you get this theta from PLL. So if these things happening, it means that, when you have this converter and grid goes to outage, in fact, we have no reference for the PLL, and then PLL give the 0, and then it goes shut down. Okay, this is the problem. So they have some solution for that one. We see later. Okay, good. So is it clear, 100%? Nobody say yes. Oh. Yeah.
They don't have power subject.
Okay.
They don't have this.
Doesn't matter. Okay, I can speak Spanish, Danish, English, Persian, Finnish. So today probably if I decide to stay India, in 1 year probably I speak Indian. So you're here, you try to maximize your knowledge actually. And if you know these things, so why you are here?